On April 16, 2025, the scientific community was abuzz with a discovery that could reshape humanity's understanding of life beyond Earth. Observations from the James Webb Space Telescope revealed unusual atmospheric chemicals on the exoplanet K218b, located 124 light-years away. The planet's atmosphere contained high concentrations of dimethyl sulfide and dimethyl disulfide, compounds closely associated with biological activity on Earth. Scientists calculated that the discovery of these molecules on K218b had a 99.7% certainty of being evidence of life. This groundbreaking finding quickly became one of the most significant scientific discoveries of the decade. But this wasn't the only intriguing event unfolding in April 2025. In an unexpected twist, reports of mysterious drones spotted over sensitive military sites across the United States reached a fever pitch. For weeks, authorities grappled with these unidentified aerial vehicles, raising questions about national security and leaving many wondering about the intentions behind these incursions. In today's video, we will delve into the captivating narratives surrounding both of these events. By weaving together the latest scientific findings, eyewitness accounts, and official statements, we aim to shed light on these enigmatic occurrences and explore their potential implications. The discovery of possible life on K218b sent shockwaves through the scientific community and captured the attention of people worldwide. With its promising signs of habitability, this exoplanet has emerged as a beacon of hope in the search for extraterrestrial life. But what exactly makes K218b such a compelling candidate for hosting life? And how does the presence of dimethyl sulfide and dimethyl disulfide support this theory? Join us as we embark on a journey to unravel the mysteries of this intriguing world and the fascinating discoveries that have sparked our curiosity. As we continue to explore the intricacies of K218b, it is important to consider the methods and technologies that have enabled us to study this distant exoplanet. The James Webb Space Telescope has been instrumental in our quest to understand the characteristics of K218b and detect the presence of life there. This cutting-edge telescope has revolutionized our ability to observe celestial bodies and analyze their atmospheres. Through spectroscopy, the James Webb can break down light that passes through faraway planets' atmospheres, allowing us to identify specific chemical compounds present on their surfaces. This capability has opened up new frontiers in our search for life beyond Earth. One of the key features of K218b that sets it apart is its location within the habitable zone of its star system. This region, also known as the Goldilocks zone, is a crucial parameter in the search for extraterrestrial life. A habitable zone is the area around a star where conditions are suitable for liquid water to exist on the surface of a planet. Liquid water is considered essential for life as we know it. Therefore, the presence of water in a habitable zone significantly increases the likelihood of finding habitable worlds. K2218b resides within the habitable zone of its star, indicating that it could potentially harbor liquid water and therefore support life. The exciting discovery of dimethyl sulfide and dimethyl disulfide on K218b has reignited the debate about the possibility of extraterrestrial life. These compounds are typically associated with biological processes here on Earth, making their detection on K218b particularly intriguing. Dimethyl sulfide, or DMs, is an organic compound that on Earth is primarily produced by living organisms, such as phytoplankton in our oceans. It is released into the atmosphere and can travel long distances before breaking down. Dimethyl disulfide, or DMDs, is also an organic compound that shares similarities with DMs in terms of its production and atmospheric behavior. The presence of these compounds on K218b suggests that the planet could have a liquid water ocean similar to Earth, which is a critical factor in supporting life as we know it. While the discovery of DMs and DMDs is incredibly exciting, it is important to approach this discovery with a healthy dose of skepticism and critical thinking. Scientists are cautious not to make premature conclusions and are conducting further analysis to confirm these findings. One of the key aspects of the scientific method is the need for verification and replication of results. Scientists are currently working on gathering more data to verify the presence of these compounds on K218b. They will also attempt to rule out any non-biological processes that could have led to the formation of these molecules. Moreover, scientists are exploring various scenarios to explain the potential presence of life on K218b. One intriguing possibility is the existence of a vast global ocean covering the planet's surface. If confirmed, this would be a significant breakthrough, as it would provide strong evidence supporting the theory of panspermia. Panspermia is the hypothesis that life can arise independently on multiple planets or celestial bodies, and that it can be transported between them. The discovery of a global ocean on K218b would suggest that conditions necessary for life are widespread in the universe, increasing the likelihood of finding life elsewhere. However, it is also important to consider alternative explanations that do not involve life. Geological activity, chemical reactions, and other natural processes could potentially account for the presence of DMs and DMDs on K218b. Scientists are actively investigating these possibilities to ensure that any conclusions drawn are well supported and robust. The presence of dimethyl sulfide and dimethyl disulfide in the atmosphere of K218b has ignited speculation about the nature of life that might exist on this distant exoplanet. While the discovery is still awaiting further confirmation, it has prompted astronomers to consider the possibility of life forms that are radically different from what we know on Earth. Some astronomers have suggested that the presence of these compounds could indicate the existence of life forms that rely on a different solvent besides water. On Earth, DMs and DMDs are primarily associated with phytoplankton in our oceans, which are microscopic organisms that form the basis of marine food chains. However, on K218b, where the atmospheric pressure is approximately 30 times greater than Earth's, the conditions may be suitable for life forms that utilize a different solvent, such as methane or ammonia. Methane is a common compound found on many celestial bodies in the universe, and it has the ability to dissolve certain organic compounds. If confirmed, this would expand our understanding of the diverse forms that life can take, and challenge the conventional view that life, as we know it, must necessarily be carbon-based. It is also worth noting that the detection of DMs and DMDs does not necessarily imply that K218b is teeming with life. The presence of these compounds could be indicative of a single large body of water, such as an ocean, rather than an indication of widespread or diverse life forms. Further observations and analysis will be needed to determine the extent and complexity of any potential life on K218b. Amidst the excitement surrounding the discovery of dimethyl sulfide and dimethyl disulfide on K218b, it is important to recognize the challenges and uncertainties that remain. While the discovery has generated immense enthusiasm, scientists urge caution and skepticism until further evidence is gathered. Making premature claims or drawing definitive conclusions based on tentative evidence could undermine the scientific process and potentially lead to confusion or disillusionment. Scientists are working diligently to gather more data and conduct rigorous analysis to verify these findings. Transparency and peer review play a crucial role in ensuring the validity of these discoveries. Scientists involved in the research are sharing their data and findings with the broader scientific community, allowing other researchers to scrutinize their work and propose alternative explanations. This collaborative approach helps to identify any potential biases, errors, or oversights, ultimately strengthening the reliability of the findings. As we continue to explore the mysteries of K218b, it is essential to keep in mind the vast distances and timescales involved. The light from K218b takes 124 years to reach us, meaning that any observations we make are of the planet as it existed over a century ago. This vast time difference poses challenges for real-time analysis and understanding the dynamic processes occurring on the planet. Scientists must rely on sophisticated models and theoretical predictions to interpret the data they collect, which introduces a degree of uncertainty and potential for error. Despite the challenges and uncertainties, the discovery of dimethyl sulfide and dimethyl disulfide on K218b represents a significant milestone in our search for extraterrestrial life. The possibility of life on this distant exoplanet has captured the imagination of people worldwide and has sparked intense curiosity and debate. As scientists continue to investigate these findings, the pursuit of knowledge and understanding drives humanity's quest to explore the unknown. The discovery of possible life on K218b and the perplexing reports of mysterious drones flying over military sites have captivated the public's attention. While these events may seem unrelated at first glance, they highlight two intriguing aspects of human curiosity: our innate desire to explore the cosmos and our fascination with the unknown. The discovery of possible life on K218b has captured the public's imagination, igniting discussions about the nature of life beyond Earth. Similarly, the reports of mysterious drones flying over military sites have sparked curiosity and speculation about their origins and purpose. Both of these phenomena tap into our innate desire to understand the world around us and our fascination with the mysteries that lie beyond our immediate perception. These instances reflect a broader cultural fascination with the paranormal, the extraterrestrial, and the unexplained. We are naturally drawn to stories that challenge our understanding of reality and push the boundaries of what we consider possible. Whether it's the search for extraterrestrial life or the investigation of unexplained aerial phenomena, these narratives capture our attention and fuel our curiosity. Furthermore, these events highlight the power of storytelling in shaping our understanding of the world. The way these stories are presented and interpreted can significantly influence how we perceive these phenomena. Media narratives often play a crucial role in shaping public opinion and can contribute to the sensationalization or downplaying of certain events. It's important to approach these stories with a critical mindset, considering the source and the potential biases or agendas at play. In conclusion, the mysterious sightings of drones over military sites and the tantalizing possibility of life on K218b reflect two distinct yet intertwined aspects of human curiosity: our inherent desire to comprehend the world around us and our fascination with the unknown. These phenomena captivate our attention and ignite our imagination, reminding us of the boundless wonders that exist beyond our everyday experiences. As we continue to explore the mysteries of the universe and the intricacies of our own planet, we must embrace a spirit of inquiry, critical thinking, and open-mindedness to fully appreciate the extraordinary discoveries that await us.